With example 18, we see our division inside the integrand, so we're looking at the potential of making u equal to some or all of the denominator. In this case, it's going to be the entire denominator because there's no exponent that the entire denominator is raised to. So u will be equal to x to the fourth plus 1. In doing so, we can calculate du to be the derivative of that, which is 4x cubed dx. That's an x right there. Sorry about that. All right, so we have the x cubed and we have the dx. We don't have the 4. All right, so we're going to toss the 4 on the inside and the 1/4 on the outside to counterbalance it. Now we're ready to make our changeover. So we're going to have this be equal to the integral with 1/4 out front. The numerator is 4x cubed dx, which is our du. So we're going to have du over x to the fourth plus 1, du over u. That's a nice antiderivative that we worked with before. We know this is leading us to the natural log as far as our antiderivative is concerned. But before we do that, we need to change our bounds. And we have 0 and 2. We have to do 0 to the fourth plus 1. Well, that's going to be 1. We got to do 2 to the fourth plus 1. 2 to the fourth, 2 times 2 times 2 times 2, that's 16. And we have to add 1, so our new upper bound is going to be 17. All right, now we're going to plug the 17 and the 1 in, but not yet. Now we take the antiderivative. The antiderivative, as we mentioned a moment ago, is going to be the natural log of the absolute value of u, and that's being evaluated from 1 to 17. We still have our 1/4 out front. All right, so what's the deal? We have 1/4, the natural log of 17. 17 is positive, so we don't need the absolute value symbols anymore. Minus 1/4, the natural log of 1. And that's a correct answer, that's fine. And just keep in mind that the natural log of 1 is 0, so really this entire term right here is just 0. So we're really looking at the natural log of 17 divided by 4 as a final answer. Number 19, we have some trig involved. All right, we see that we have the sine of 2x. Okay, so that's the sine of something more than x. That means that's our inner function. So we're going to make u equal to 2x, which means du is equal to 2 dx. We have the dx, but we don't have the 2, so we're going to need to throw the 2 in there and counterbalance it with the 1/2 on the outside. All right, now that we have that squared away, we make our changeover. So we're looking at 1/2, the integral. Sine is not part of our u or du, just as e was not part of it back with example number 17. So that's going to come down into our new integrand as well. We're going to have the sine of u du, because du takes over for the 2 dx, since they are one and the same. Our new bounds, well, we have to double our old bounds. 0 doubled is still 0. Pi over 2 doubled is now just pi. So we have 1/2 the integral from 0 to pi of sine of u du. And that's a nice antiderivative. We know that sine antiderives to the opposite of cosine. I'm going to take that opposite sign, I'm going to throw it in front of the 1/2. So we are looking at negative 1/2 the cosine of u evaluated from u equals 0 to u equals pi. So we have to know our trig chart again, so hopefully you still have that memorized. So we are looking at negative 1/2 the cosine of pi minus, and I'm going to just practice safe math here and keep my parentheses going, negative 1/2 the cosine of 0. And on the on the AP exam, that you're expected to know your trig values, right? So the cosine of pi, that's equal to negative 1. So what we have here is negative 1/2 times negative 1, which is just going to be 1/2. And then we have minus negative 1/2 times the cosine of 0. The cosine of 0 is 1, so we're subtracting negative 1/2, which means we're really adding 1/2, which means our final answer is just all that work just for 1.